In this section, we are going to talk about the relationship between the angle pairs that we learned in 3.1 and how they relate to parallel lines and proving that lines are parallel. So we're going to look at each of the angle pairs. I'm going to talk about when we know that the lines are parallel and when we know the relationship between the angles to prove that the lines are parallel. So a couple of things to notice is that when you have a drawing, remember that on a diagram, you'll know if lines are parallel based on these little arrows that are on the diagram, or you'll be given information in the directions that say this, L is parallel. So these two lines up and down right next to each other mean parallel. So L is parallel to M. So marked on a diagram with a little arrow, or these two straight lines to say that they're parallel in the directions. When we take a look at this diagram, so these two lines are parallel, it's marked in the diagram, and so what I'm going to do is actually just highlight this top set of angles here, and I'm just going to label them 1, 2, 3, and 4 so you can see them, because what I'm going to do is pick them up and move them so you can see that they're mobile now. So if the two lines, when we have two parallel lines, we know from Algebra 1 that that means that the slopes are the same. And what that means is that these two lines are going to create the same angles. So when I move this down to this set, do you see how all four of these angles are the exact same measure as these? So these four picked up and set down will be the same as the four down here, okay? So the corresponding angles, okay, in each set, in this bottom set and then in this top set, are going to be equal to one another, or the geometry word for that is congruent. So this happens every time you have parallel lines, that the corresponding angles are going to be equal to each other. So that would be any of these sets that I showed you land on top of each other. Okay, so this angle 1 with this angle. Okay, let's put some other numbers in here. Let's put 5, 6, 7, and 8 here. So angle 1 and 5 would be equal. Angle 2 and 6 would be equal. 3 and 8. 4 and 7. So all of those corresponding angles are the same. So if you had expressions in there, you could set them equal to each other. Numbers, you would know that they're the same. So then we're also going to be looking at how to prove that lines are parallel. So if you take a look at this diagram, we don't see any markings on this picture that shows that the lines are parallel to each other. But if we were to see in the diagram, okay, so let's say that we had this angle given to us as 140 and this angle given to us as 140. So if we saw a diagram like this where we saw any set of corresponding angles being congruent to one another, so angles in the same relative spot, so if we know that we have corresponding angles that are equal or congruent, then we automatically know that the lines are parallel. So this forces L to be parallel to M. So if you look at a diagram and see any corresponding angles equal, automatically those lines are parallel. So when we have alternate interior angles, okay, so again, given that we have parallel lines here, okay, so we see on this diagram, then what we actually know about alternate interior angles is that they're congruent as well, congruent or equal as well. Okay, so this angle here is going to be equal to this angle here, provided that L is parallel to M. So if this is 80, this is 80. Or if this is 130, then this is 130. And this other set as well. So this set here would be equal to this set. So given parallel lines, automatically alternate interior angles are congruent to each other. So if you see in a diagram, okay, so if you see in a diagram that this angle is congruent to this angle, so it could just be marked with arc marks like that, or you could have an actual measurement in there. So if you see a set of alternate interior angles that is equal, then you know that the lines are parallel, okay? That forces the lines to be parallel. Then you know that they're hitting at the same slope. Alternate exterior angles. So when we know that the lines are parallel, then these alternate exterior angles here are also congruent. So this set, and then also this set. So then again, if you don't know whether the lines are parallel or not yet, but you see a diagram, okay, that has this angle congruent to this angle, any set of alternate exterior angles equal to one another or congruent, then automatically then you know that the lines are parallel. So then you can conclude that the lines are parallel. Same side interior angles. So remember, same side interior angles is like this angle here. So if we had this one was 140, and then this one would actually end up being 40 because the corresponding angle here would be 140 since the lines are parallel. And then we have a linear pair here that should total 180. So we would have this one at 40. So for same side interior angles when the lines are parallel, the same side interior angles are actually supplementary, meaning that they add up to 180 every single time you have parallel lines. So knowing that the lines are parallel forces the same side interior angles to be supplementary. So then again, this set, alternate interior would be equal. Same side would be supplementary. So if in a diagram you see that, if you see that same side interior angles are equal to 180, okay, so if we had if we had 40 here and 140 here, if you see that given to you in a diagram, then automatically the lines are parallel. And then this is the same for same side exterior, okay? So if the lines are parallel, then same side exterior are also supplementary. Okay, so same side exterior would total 180. And then if you're given a diagram that you don't know if the lines are parallel yet, but you see angles given to you as same side exterior and you see that they total up to 180, then you know that the lines are parallel. Okay, then you automatically know that those are parallel lines. Okay, so just a recap on that, make sure that you know all of these and you know the equations for them. So alternate interior, alternate exterior, and corresponding. When you have parallel lines, these are all equal to each other. Okay, so that the formula, that we talk about would be blank equals blank. The two angles are equal to each other when you have parallel lines. And if you ever see them equal, they force parallel lines. Then the same side ones, okay, so same side interior and same side exterior. Okay, so those S's, same side interior, same side exterior, those are supplementary. So they add to 180. So those are kind of your two options. They're either equal to each other with parallel lines or they're equal to 180. So let's take a look at a few examples here. So fill in the missing angles to determine if the lines are parallel. So when you're determining, this means you don't know yet. So you're looking for relationships on the picture. So if you don't know, that means the only thing you really do know from the picture is that straight lines equal 180 and vertical angles are equal to each other. So we're going to look at these as kind of two separate sets of angles. So we're going to ignore this because we can't connect these two lines since they're not parallel. So we're going to look at these ones up here and fill them in. So across from 75 is the vertical angle of 75. Then next to it is a linear pair. So these would have to total 180. So this one would be 105. And then this one would be 105 by vertical, again, or right next to each other, 180. Okay, so then we'll go to this bottom set and fill in from this one. So again, we'll ignore this top. We're not looking at the top to fill this in, okay, because these aren't parallel lines. So vertical angles, we get 105. Linear pair, right next to it, you get 75. And across from that vertical. So now when we take a look here, then we'll compare top to bottom. If these are parallel lines, all of those corresponding angles, or just any set of corresponding angles, is going to be equal. Okay, so if we picked up this top set and set it down, this 105 would land on this 75. Are they the same? And the answer is no. So these are not parallel. They have to be the exact same slope or the exact same angle formed here. So when you take a look right here, this angle needs to be the same as this angle. Okay, and they're not. Those corresponding angles need to be the same. Okay, let's take a look at the next one. So we've got across from the 100 is a vertical. Okay, next to the 100 is 80, since those are supplementary. And you can fill in all the angles, or when you notice one set of corresponding, that's going to force the whole picture to be the same. Okay, so this bottom left and this bottom left are equal to each other, so those corresponding angles are equal, meaning the lines are parallel. Okay, let's take a look at this next one. I'm going to highlight the lines here. So we've got this line and we've got this line. Those are the two that are potentially parallel, and then this transversal. So when we take a look here, we've got this angle and this angle are corresponding. This one is 110 down here. This one, 40 plus 80 with angle addition, is 120. Which are not the same. So these two lines are not parallel because the corresponding angles do not equal each other. Across from here is 15, if we wanted to do that. Across from, and then I would fill in maybe next to it. We didn't even necessarily need this. Because if you're looking for corresponding angles, you could have done this one. So you could have done the 180 minus 15, okay, which is 165 for this angle right here. So then this angle is corresponding with this one, and they aren't the same measure. So these are not parallel. Again, because corresponding angles aren't equal, meaning they don't hit at the same slope. On number 5, some people will get this wrong because they'll see two equal numbers, okay, but these are not the corresponding angles, right? So if we do a linear pair here, you'll get 100 for this angle right here. This angle is the corresponding angle with this one. Okay, so these two angles are corresponding, again, not the same. So corresponding angles here are not equal, so these two lines are not parallel. Next one, maybe you notice that this is an alternate interior angle with this. Okay, so alternate interior angle, if I add these two together by angle addition, I get 110. This one's 110. So these are parallel because alternate interior angles are equal, and that was one of the things we learned. So you can compare alternate interior, you can compare alternate exterior, corresponding, same side interior. So a way that you can compare same side interior, if we look at number 1. So if you look at these were same side interior. These need to equal 180 in order for those to be parallel, and they don't. Those are 210 together. Okay, so if you had two same side interior angles, they would need a total 180. All right, then let's take a look at putting some algebra in this. So one thing to notice about this picture is you see the arrows on the lines. So we know that the lines are parallel. So now we can look for any of those relationships between the angles. So in this one, I would take a look at your angles where you have expressions. Okay, so I have this angle and this angle. So if I just kind of draw this picture more simply off to the side, these are the angles that I have. Here's my parallel lines. So these two angles are on the outside, so they're exterior angles, and they are on different sides of the transversal. So these are alternate exterior angles. And what we just learned is that when we have parallel lines, alternate exterior angles are equal to each other. So we'll actually set these equal to each other to solve for y. So 3y plus 53 is equal to 7y minus 55. And then you can just solve. So I'm going to subtract 3y from both sides. Get 53 is equal to 4y minus 55. Get the 53 and the 55 together by adding 55 to both sides. So then we'll get 108 equals 4y. Divide 4 to both sides. So you get y equals 27. Then you could always plug it back in to check that these two angles are the same. So you do 3 times 27 plus 53. So you get 134 for this one. And then 7 times 27 minus 55. And you'd get 134 for this one as well, just to check your work. Okay, these two say determine if the lines are parallel. So determine means we don't know yet. And you can see this on these lines. You don't see them marked as parallel to one another. So when this happens, you can't compare the angles on the different sets of lines. So I can't take this 6x and put it with these 130 or the 3x minus 4 because I don't know if these two lines are parallel. So what you want to be looking for is vertical angles or linear pairs. Okay, things that you know without the lines being parallel. So what I see here is vertical angles, okay, on the same set of angles, so like this lower part. So vertical angles are equal to each other, so we'll set these equal to each other. That way we can solve for x, knowing that those are equal. We don't know about this 6x plus 2 yet. So let's add 4 to both sides. And we get 134 equals 3x. Then divide by 3. And we get 44.67 equals x. So now you're going to need to plug this back in to see if this angle is the same, okay? So we'll plug that back in. We actually got 0.6 repeating. So when you do plug it in here with your calculator, you're going to want to put in a bunch of 6s. So when we go here to do 6 times 44.66666, put in a bunch of them, plus 2. Okay, so 44.66666 times 6 is 268 plus 2. All right, so something. So we ended up getting 270 for this, okay, which is not the same as, it should have been the same as 130 because these are corresponding angles here. This angle is a corresponding angle with this one, so these should have been equal, okay, and they are not equal because we got 270 once we solved for x. So then these two lines are not parallel. Okay, so you go based on something you know these two angles have to be equal because they're vertical, solve for x, plug it back in, check if the relationship happens to make the lines parallel. Okay, so on this example, again, we see vertical angles here. We can't compare from line to line. Okay, so set these two equal to each other because they're vertical angles. We know that's true. Solve. So we'll subtract 5x from both sides. So then we get 2x plus 2 equals 12. Subtract 2 from both sides to get 2x equals 10. Divide by 2. And you get x equals 5. Okay, now you need to plug it back in here. And when you plug it back in, you've got two options, okay? Because then you're going to compare it to this other side. So I see a set of alternate interior. So this one and this one are alternate interior. So if the lines are parallel, those are going to be equal to each other. Or this 37 and this one are corresponding. They're both in the lower right-hand side. Okay, so we should be getting 37 if these two lines are parallel. So let's plug in the 5. So I'm just going to plug it into this one. So 7 times 5 is 35 plus 2 is 37. So I put it into here. See that those two are equal to each other. So these lines are parallel because I saw alternate interior angles were equal. If you had plugged it into this one, you would have said corresponding angles are equal because you would have noticed this one and this one were both 37. So go based on something you know, vertical or linear pair, then plug it back in. All right, last example. In this one, we know the lines are parallel. So given M is parallel to N, find X and Y. Okay, so what I would do in this case is look to see where you have the same variable because you can't put X's with Y's. So we're going to look and see that there's an X in this angle and this angle. So compare these. What type of angles are these that are right next to each other making a straight line? Those are linear pairs. So linear pairs total 180. So we will add these two angles together to equal 180. Solve. So we'll do 3x and 8x together to get 11x. 8 and 18 to get 26. Subtract 26 from both sides. So you get 11x equals 154. Divide by 11. To get x equals 14. Now you need to solve for y. So we're going to have to plug 14 back in to figure out how big these angles actually are so that we can find y. So I'm going to plug it into this one because I know that alternate interior angles are equal to each other. You could plug it into the 8x plus 18 and use that same side interior or supplementary. I like to set things equal to each other more, so I'm going to put it in there. So I'm going to do 3 times 14 plus 8. So 3 times 14 is 42, plus 8 is 50. So I know that this angle here is 50 degrees. Since the two lines are parallel, alternate interior angles are equal to each other. So that means y minus 16 is equal to 50. I would add 16 to both sides to get that y equals 66. And we'd be done.